Finally, let's move on to section 4 of this notebook. And this one corresponds to pre-calculus, Math 1650 of UNT system or equivalent. A lot of students will probably want to skip the first 3 videos and just move on to this one. And that's okay. Just go ahead and go through with this, and if you understand everything, that's fine. If you don't, and if you need to review some of those, then you can use the other videos. We're going to key upon 2 topics actually. Composite functions first, and then probably in separate video, transcendental functions. Let's talk about composite function. What is a composition? Applying a function twice. G first and then F. And then we use circle notation or repeated application notation. They're equivalent. Here are some examples. F and G are given kind of like this, and let's find out what is, well, F circle G, G circle F, and so on. Let's do just a couple of them. Okay, let's go ahead with, this example, F circle G, this one. So here it is, F circle G is equivalent to F of G of X, and if we have multiple parentheses, order of operation says inside first, so let's find out what G of X is. It is x squared minus 1 according to this definition over here. So substitute that G of X by x squared minus 1. And what do we have? From the definition of F, we have square root of x squared minus 1, and that's my answer here. That was easy, wasn't it? How about G circle F, the next one? Similar, except that inside is F, so that's where we have to start. So F of X is square root of X, as you see here, so G of square root of X. And now substitution. Square root of X will replace X in this definition, so what do you have? Square root of X squared, which will cancel into just X. Okay, the other problems can be done rather similarly, and that was just too simple even for a warming up, so let's move on. Let's move on to a little bit tougher examples this time, and then this time we have to identify functions when functions themselves are known. And here we go. F of X is given by the square root of X function. G of X is given by X plus 1. And let's find out a new function H, where G is F circle H, and a new function K, so that F is K circle G. So these are 2 different problems, so let's go with the first one. Okay, here we go. So G is F circle H. That means G of X is F of H of X, right? So let's just write it out like that. But actually I found it a little bit more convenient to have G of X in the right hand side. It's okay to do it the other way, but for convenience I did that. So I just rewrote the circle notation into F of H of X, and then H of X is what I'm looking for. Now if we have computation, then we have to start the computation from the inside, but this is different. I don't know what's inside. The information is coming from the outside. So what is G of X? We have to consider that. And what is F? We have to consider that. G of X is X plus 1, so we substitute G of X by X plus 1. A little bit tougher substitution. F of X is square root of X, so F of H of X. So H of X will be substituted here. So we have square root of H of X. Good. Now we will have square root of H of X, and you're looking for H of X, so it's easy to find out. All I have to do is square both sides, and then if problems specifically ask you to do, then you may have to expand out, and there you go. Okay, that was not too bad. Let's move on to slightly tougher example this time. Let's find out K, and this is harder because K is in the middle. You'll see what I'm talking about here. So let's express F equals to K circle G into repeated application notation. So F of X is K of G of X, but then again I found it a little bit more convenient to switch the order. k of g of x equals to f of x. Let's write it like that. And then let's do some translation here. F of x in the right hand side is easy to handle. That's going to be substituted by square root of x. What about k of g of x? G of x is equal to x plus 1, so I'm going to get x plus 1 in place of that g of x. Consequently, we get that. So far, nothing spectacular. Something spectacular will take place from now. Here, left-hand side is expressed in terms of x plus 1. I want it narrowed down to x. I cannot do that in usual fashion. This is not algebra. This is not k times x plus 1. No, it doesn't work like that. So it is necessary to express the right-hand side in terms of x plus 1 as well. Because this one and that one have to be the same. And this one is completely out of touch. We cannot change, we cannot do any manipulation here. This is a function, remember, not algebraic operation. So replace x by a certain expression by x plus 1. How do we do that? Are you ready? Okay, here we go. Rewriting x by x plus 1 minus 1, we got everything on the right hand side expressed in terms of x plus 1. No more x, no other notation, just x plus 1. Now we can replace this x plus 1 by x in both sides simultaneously. That's the final answer. Okay, I think this problem was worthy. So if you're a little bit unsure, you can review this video over and over again, and also you can download this notebook and study it. Next topic, inverse function. Oh, that's too simple. If you compose inverse function, you get original answer back. That's the idea behind inverse function. Example for inverse function. Well, okay. F inverse of 1/2. Oh, it is just 1/2. Nothing to think about. F inverse of 1. Okay. That is gonna be a function. That's gonna be an equation, but I don't want to spoil the fun, so I'll just leave that to students. Let's move on to the graph example. Okay, here we go. We have a graph of a couple of functions, f and g respectively, red and blue, and we have to answer some function value problems and then some equations. And these are very, very important examples, and then you have to use some critical thinking skill to find out. After all, once you step outside mathematics classroom, you deal with graphs a lot. If you find yourself in STEM industry or actually any other company, you deal with graphs all the time. The performance of your company or stock market or some chemical reactions, biological reaction, a lot of things are given by graphs, and then you have to backtrace the graph and then get numerical data. And that requires some skills, and that's kind of thing we are talking about here. Easiest one. So let's find out f circle g of 2. In other words, let's find out f of g of 2. Come on, open it. So here we go. Just re-express it in repeated application notation, f of g of 2. Good. Now, if we have algebraic expression, then you'll find out what g of 2 is, and then plug in, and then you have an answer. You do not have algebraic expression, so you have to find out from the graph. The question, which graph, blue or red? I want to find out what g of 2, the inside is. So which graph do I have to look at, blue or graph? Blue or red? The answer is blue, because it's g. And then g of 2 is 3. I showed this answer a bit too prematurely. Start from 2 and go to the blue graph, and their y-coordinate value is function value, so that's 3 right here. Okay, now what? I have to find out, I just found out this whole thing is the same as f of 3, so all I have to find out is now f of 3. Which graph do I have to look at, blue or red? I'm looking for f of 3, so I have to look at graph of f, that's red. And f of 3, so how do I find it out? X equals 1, 2, 3, and then pointer on the graph is right over there, and that y-coordinate value is my function value. That's 4, isn't it? 4. Okay, we have similar problem down here, so I'll leave that to students. And then let's move on to some other problem like this one. Okay, let's move that part over there and then study that one. Okay, this time we have to find out x, and then information is coming from the outside. So this is going to be backward problem, and then we just went through a backward problem finding out h and k, and they were difficult, weren't they? So this is going to be a little bit more difficult too. Backward information, how do we get that? 5, we have to start from 5, and the function value is 5, and which graph do we have to use? Blue or red? Information is coming from outside, so we have to go from outside to in. So outer function is f. So we have to look at the red function. So for which x-coordinate value on this red graph, the y-coordinate value is 5. Function value is 5, so y-coordinate is 5, and we have to find out the x-coordinate value here. I'm looking at only this point. That x-coordinate value is 2. So do I say x equals to 2, for example? Do I write x equals to 2 here? Actually, no, that's not good. That's not complete because we didn't consider g yet. So function that value is 5, inside is 2, which means inside the g of x is 2. That's what I got from my red graph. Now what do we do with g of x is equal to 2? That's another equation to solve using the graph. And do I have to use blue graph or red graph? This time function is g, so I have to use the blue graph. So g of x is equal to 2, so function value is equal to 2. Y-coordinate is equal to 2, and that x-coordinate value, oh, I have 1 point, I have the second point. So we'll have 2 x-coordinate values, and those are x equals to 4 and x equals to 6.5 respectively. X equals to 4 right here from here, and then from there 6.5. So let's recap this. From the outside we got f of g of x equal to 5, so we started from the outside. Outside function is f, so we started from the red graph. So y-coordinate is 5, and then we track down, x-coordinate is 2, but it's not x that is 2. G of x is equal to 2. That gives me the second graph. G of x is 2, so y-coordinate is 2, oh, here. And then function value is 2, and we have find that x-coordinate value, 4 and 6.5. Let's do this one more time. Let's do this one. I don't know if I'll have enough time to that. G of f of x is equal to 3. Let's find out. So if I use convert this g of f of x into g circle f into g of f of x, we have something like that. Information is coming from the outside, so we have to use function g, and that's blue. So blue graph, and then function value is 3. The x-coordinate value is 2 and 7, but that's not x that is we are looking for. F of x is 2, f of x equal to 7. We have a couple of equations of f, which we'll have to find out through red graphs. And then f of x equal to 7 will not be possible because all we can get is 5. and here.